This is lesson 6.3 on conditional probability. We'll start out with some vocab. It is the probability of event A occurring given that event B occurred. What we mean by that is the probability of something happening given that we have knowledge that something else already took place. So if we jump into examples here of just daily life, the probability that a cloudy day will result in rain is different if you live in Los Angeles than if you live in Seattle. That means that in certain cities, for example, in Seattle, when you see clouds all the time, you don't know if that's necessarily going to result in rain. Whereas if you're in Los Angeles, it's a different story. There's a condition of what city I'm in that changes what clouds will do. Our brains on a typical day calculate this type of thing all the time. Given evidence of some sort, your brain helps translate that and says how much do you believe that a certain event will occur given all the other information that you have. So let's take a look at a more concrete example. We know the probability of getting an even number on the throw of a die is 0.5 because we can get 2, 4, or 6. We're going to call this event A. Now suppose that we throw the die and the result is a number that is 3 or less. So given that the result is 3 or less, given that it's 1, 2, or 3, we'll call that simple event B. Would the probability of observing an even number on that particular throw still be 0.5? Well, given that these are our only 3 options, the answer is no. No, it's not. There's actually only 3 options available, and this is one of them. So, in other words, with the introduction of a particular condition, the event B, we change the probability of a particular outcome. This graphic right here, called a Venn diagram, shows that we have a reduced sample space. We no longer have 6 options, we only have 3, given that event B occurred. The only even number in the sample space here is this 2 that's been double highlighted. So we conclude that the probability that A occurs, given that B occurs, is only 1/3. Because there's only 3 choices, and one of those choices is what we're looking for. Now the way that we write that is a little bit goofy. We say P of, so the probability of A, given that B occurred. So again, that reads the probability of A given B. So we always put the thing that we're looking for first and the condition that happened second. So for this, we would write probability of A given B is 1/3. Let's keep looking at this. If A and B are 2 events, then the probability of event A to occur, given that B occurs, is called a conditional probability. We mentioned that above. We denote it with the symbol P of A vertical line B, which reads the probability of A given B. However, we want to show a systematic way of calculating conditional probabilities. So we take the ratio of the probability of the part of A that falls within the reduced sample space, so the intersection or overlap of A and B, and we divide that by the total probability of the reduced sample space. Let's take a look at that. So to calculate the conditional probability for A, given that B occurred, we take the ratio that they both occur, so that's this means the probability that A and B occur, that's what that U symbol, it means union, so probability of A and B, and you divide it by the probability of B happening. And that formula will allow you to calculate the probability of A given B. So let's go ahead and use the example we used earlier. And say event A is observing an even number, event B is observing a number less than or equal to 3. So if we use our formula, What is the probability that we observe an even number and a number that is less than or equal to 3? Well, if you remember from our graphic here, 2 is the only number that meets these criteria. So we would say P of 2 and put that in our numerator. That's the probability of A and B occurring. It's the only time that both of those events happen. Over here we have probability of B. Well, the probability of observing a number that's less than or equal to 3. We could get a 1, we could get a 2, or we could get a 3. So now we just need to add up our probabilities. Well, the probability of getting a 2 is 1/6. The probability of getting each of these numbers is 1/6, and if we add them together, we get 3/6. And then if we do 1/6 divided by 3/6, it's going to result in 1/3 as our final answer. And that's our conditional probability, the same result that we had mentioned earlier. Now we're going to look at tables to find conditional probability. Here's an example. The students at high school were asked to name their favorite lunch entree. The results are shown below. We have pizza, hamburgers, or burritos, and then we have it divided up into the different classes. Suppose we select a random student. We want to find the probability that we get a senior who prefers pizza. Well, the probability of finding someone who is a senior and someone who prefers pizza, we just need to look for the intersection of those two things. We look for pizza, we look for seniors, and we look where they overlap. And we see that there's 85 out of a grand total in this whole table of 1,130. By the way, if you haven't seen a table like this before, it's called a two-way table. And the way that it works is if you add up all the things in one row, you're going to get the row totals here on the end. And that's going to be true for each of these rows. If you add up all of the columns, you're going to get the column total down at the bottom. And then finally, if you add all these totals together, you'll get this, or add these together, you get this. This number here is the total number of people in the entire table. So if you add each of these individual categories, again, it also adds up to this far bottom right number. So this is the total in the table. So going back to our problem, we have 85 seniors who prefer pizza. And we have a total of 1,130 students, and we got that number from the bottom right of the table. So that's going to be our denominator. So if you reduce this fraction, it goes down to 17 over 226. Let's take a look at another example using this. Suppose a student is selected at random. Find the probability that it is a senior or a student who prefers burritos. Now this word "or" means that we don't say senior burritos, only look at this. In fact, we look at anyone who is a senior or anyone who likes burritos. So all of these values added up together is what we want to know. A way to do that quickly is to just look at the total number of burritos, the total number of seniors, and subtract out the overlap where we have people who like burritos and people who like seniors, or people who are seniors. And so I'm going to just highlight the corresponding thing down below. We have probability that is a senior and someone who prefers burritos. That's our 70. That's this part that we're subtracting out, because otherwise that number gets double counted. That's why we subtract it out. Then we have our total for seniors and our total for people who prefer burritos. And that'll be those two numbers here. I'll just highlight that 70 there. Our 1,100 people, that comes from the bottom right, because we're looking at the total number of people, and that's how we get our numbers here, the denominator of our fraction. And then we just add them all together. 220 over 1,100 plus 300 over 1,100 minus that double counted box here, the 70 over 1,100. It's going to come out to 450 over 1100. And that will reduce down to 9 over 22. Look down at this last example here. Students at a high school are asked to name their favorite lunch. Suppose a student is selected at random. Find the probability that it is a freshman given that it is a student who prefers pizza. So this time we have a condition. This is getting back to the stuff we started talking about at the beginning. We want to find the probability that they are a freshman. What is the probability that they fall in this column here? However, we're not looking at the whole table anymore. We only want to know, we're already told that it's a student who prefers pizza. So if they prefer hamburgers or burritos, we want to ignore that information. And since we're only dealing with that condition, I'll scribble out this total line too. Because we know it's a student who prefers pizza, the rest of this information is extraneous. It's no longer useful to us. So we can get rid of it and only focus on the pizza row. So now, what is the probability that we have a freshman? Well, there's 90 freshmen here, and the total for the row, which is all we have left since we eliminated everyone else, is 300. So instead of going to that number in the bottom right, we're looking at the total for the row because we were told that it has to be a student who prefers pizza. So now we're left with 90 out of 300, and that's going to be our ratio. I'll just write that down here for you. And if you were to reduce that, you would have 9 over 30, which is equal to 3 over 10. Finally, one thing that's worth noting, and that might be a little confusing at first, is that the probability of finding a freshman, given that you have a student who prefers pizza, is different than the probability of a student who prefers pizza, given that you have a freshman. Because if you say, given that it's a freshman, that last part after the vertical line, that means that you only look at freshmen. You scribble out everyone else, and then you say, what is the probability that it's a student who prefers pizza? Well, 90 out of the new total here, which is 290. So it would be 90 over 290, which is going to reduce down to 9 over 29. And that's conditional probability.